This is 4.2. We're going to talk about circles. And to connect this to what we did a little bit yesterday, we had a concept called equal distance. And equal distance led us to a couple of different ideas. One idea was that if you had 2 points, all of the points that are equal distance between those two form a line. So that was one idea we kind of talked about a little bit briefly. This idea of a center point right here. And we want to talk about all the points that are the same distance away from that center point. Maybe we'll call it a distance r. So here's a point that's a distance r away. There's also a point this way that's a distance r. There's a point here that's a distance r. There's a point here that's a distance r. And then there's all the points in between those that are a distance r. And if we do this and we fill in all those points, you get something that looks like a circle. And that actually is the definition of a circle. It's all of the points that are a given distance away from a center point. So in order to define a circle, what we really need is a center point, and we need a radius, where the radius is the distance from the center out to the edge of the circle. Then along comes Descartes, and Descartes slaps a grid on this thing and creates x coordinates and y coordinates, and now mixes in a little bit of algebra, and now we have a different definition of a circle. It's still based on the center and the radius, but now there's some more information. The center is now located at a particular point, h, comma, k. When it comes to circles and the other shapes that we're going to be talking about, there are 2 specific radii that we want to talk about. The first is r sub x. R sub x is the length of the radius in the x direction. And the other radius is r sub y. That's the radius in the y direction. And again, this is because of Descartes, right? Because we slapped it on this coordinate axis, we now need to represent radii in terms of x coordinates and y coordinates. So we have r sub x and r sub y. Now in a circle, r sub x equals r sub y. These are the same length. And so we can do a little bit of algebra, and we can manipulate these equations, and we can come up with the standard form of a circle. X minus h squared plus y minus k squared equals r squared, where h and k are the location of your center point, the center of the circle, and r is the radius of the circle. Here's a sample problem. Draw a circle with center -1, 3 and a radius of 2. -1, 3, so that's going to be -1, positive 3. Right there's the center point. And I like to label this C, -1, 3. I like to put a C on it because that tells me it's a center point. We're going to be labeling a lot of different points, vertices, focal points, things like that. And I like to put a C to tell me that's the center point. It's not a vertice, it's not a focal point, it's the center point. And we know this has a radius of 2. So we're going to go 2 units to the right, 2 units to the left, 2 units up, 2 units down, and then all of the numbers in between. Could you write the equation of the circle in the format x minus h squared plus y minus k squared equals r squared? That's the equation of the circle. So now instead of giving you the specific coordinates of the ordered pair, well, directly giving you it, we're indirectly giving you it, but you can figure it out by looking at this equation. So we want to know 2 things. First, what is the center, the location of the center, and then what is the radius? -3, positive 2, and the radius, 1. So we would drop a point at -3, positive 2, which I think is right about there, and then we would drag our mouse out 1 unit, and that's going to draw a circle like this, and that will be our circle. How could we make this more difficult? This is standard format. What if we gave you a problem that was not in standard format? Maybe something like this. So here's a problem that's not in standard format. But you may notice we have a couple x's right there. It looks like there's some x terms. And there's also some y terms. Now, is there a mathematical technique that we could use in order to convert the blue x's into, say, a perfect square? Oh yeah, complete the square. So let's do that. We're going to say x squared minus 2x plus blank. And if we add a blank on the left, we also have to add a blank on the right. And I'm going to call this blank A. And then we go to the green part, and we'll say y squared minus 4y plus blank, and we'll call that blank B. So we'll put a B right there on the right-hand side. So a 1 goes in here for A, and a 1 also goes in that A over there. A 1 on the left and a 1 on the right. So a 4 goes on the right and on the left. And now look at this. Look what we've created here. This guy is now a perfect square. This is x minus 1 squared. And when you look at the y coordinates, you also have another perfect square, y minus 2 squared. And what do you get over here on the right-hand side? 4 plus 1 plus 4, which is 9, which is 3 squared. Where is the center? And what is the radius? Center is located at 1, 2, and the radius is 3. So we'll plot a point at 1, 2, right there. And then we'll click and drag our mouse 3 units to the right. And what that's going to do is actually draw a circle. But because we're not live online, I'll draw it manually like this. So you not only run complete the square once, you run it twice. So this flips it around. Instead of giving you the equation and asking you to make the graph, we're going to give you the graph and ask you to make up the equation. So again, really, there's only 2 things we're looking for. Where's the center and where's the radius? So I'm going to say negative 2, 0. That looks like the center. And then the radius is going to be 1, 2, 3, 4, 5 units. And if I go down, it's 5 units. If I go to the left, it's 5 units, and if I go up, it's 5 units. So I'm going to say that the center is negative 2, 0, and I'm going to say that the radius is 5. And that's your equation in standard format.